benchmark. The elevation here. So this is our first back sight. This is 11.1612. That's the data that's shown on page 10 of the first handout. So you add that to your 36 and you get 47.612. Oh man. $36. All right, so here's the 11.612. Add that to 36, which gives you a height of instrument of 47.612. The elevation of the telescope of the instrument. Okay, go up to turning point 1 now. So normally in class, you'd have 2 people at the level, one person looking through the level, reading the rod, the other person, the party chief, writing down the data. One person here holding this rod and one person here holding this rod. Back sight. Now we aim to this rod at turning point 1. That's your foresight. That is going to be 4.027. That's the data we're giving you that you're going to measure. Now to get the elevation at turning point 1, you take 47.612 and subtract 4.027. And whatever that result is your elevation at turning point 1. Okay. Everybody see that. You should understand that from your lecture. Those of you in Professor Mahalati's class have not seen this yet, but that's how this procedure goes. The level and the rods are used to establish intermediate elevations at your turning points as you progress around the figure. So you're going to do the exact same thing now over here. You're going to set up the level over here now. Okay. Actually, let's just go a little higher up. Okay. And now this rod will stay right here at turning point 1. The location of your foresight for setup 1 is the same as your back sight for setup 2. Right here. Here's your foresight from setup 1. Here's your back sight to setup 2. The rod is in the same location. Okay. There's your foresight. Okay. Now you're given your next back sight is 7.625. You use that to add to this elevation that you calculated right here, and you will get the height of instrument right here. The next foresight is 5.463. Okay, you will take that measurement, subtract it from the HI to get your elevation at turning point 2. All right, that's the procedure. And you continue doing that. One more setup here, and then 3 more coming back the other way. Okay, everybody understand this part here. Okay, so let me let me draw something else here for you. Let's just go over and I'll show you what you're going to be looking at here as far as what data you're measuring. And you'll have a setup here, a setup here, a setup here, 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 here. So you have 6 backsites listed in your data sheet. Okay, starting at the benchmark down to turning point 4. You'll have your first backsite here, your second backsite here, your third backsite here, fourth, fifth, and sixth. There's your backsites. Your foresights will be here, here. My writing's getting a little scrawny because I'm afraid to hit that delete or that erase button down there, and I want everything to go away. A foresight there, a foresight here, a foresight here, and a foresight here. Okay, and turning point 1, turning point 2, turning point 3, and turning point 4. Everybody see the relationship: backsight, instrument, height, foresight, elevation. Backsight, elevation at instrument HI, foresight, elevation, turning point 2, all the way around. Okay, everybody see that everybody see that where the numbers that we're giving you, we're giving you 6 backsites and 6 foresights. This is the data that we're giving you. The backsites are in blue, the foresights are in red. You're calculating elevations here. You're calculating, no, you're not calculating. Well, you're calculating an HI there, but you're calculating an elevation, intermediate elevation at all the turning points and at temporary benchmark. Okay. Everybody see that as far as the data and what you're measuring and what it means and what these backsites mean and what the foresights mean. Okay. So the backsites here are blue, the foresights are red, and make sure you get these in the corresponding place. All right. Questions on this? All right. One last thing. I'm going to draw this this chart real quick. Okay. So you're going to have your station. This is too light. You got a station column. You have a backsight column. You have a height of instrument column. You have a foresight column. You have an elevation. And, geez, transpose my letters there. And you have adjusted elevation. So the benchmark, here's where you're going to skip the rows. You're going to add a row here and turning point 1. You're given elevation 36.00. This is what your assignment sheet, this is what the left side of figure 3-2 should look like. You'll have 36 point, we've got to use 3 decimals here. Okay. You're given a backsight of 11.612. Your height of instrument will now go on this row. 36 plus 11.612 We already figured that out. That's going to be 47.612. Now, your first foresight is going to go down here, 4.027. You will subtract 4.027 from 4.612. That gives you your elevation right there. Okay, so here's a line in your book in your row. All right, so now you have an elevation here. So now you do it all over again. See how this flows kind of in a zigzag pattern? Now you start all over again for your next measurement. You've got your next backside over here, which will be 7.625. So you would take your elevation here, add your backside, and you subtract your foresights. Elevation plus your backside gives you height of instrument here. Okay, then you got one more row. Turning point 2. Foresight, which will be 5.463. So elevation plus backside gives you height of instrument. Subtract minus 5.463 because it's a foresight, and that gives you now the elevation at turning point 2. Again, a little zigzag pattern. And you just continue that all the way down. Okay, that's how your assignment book is going to look when you add this extra row between each of the stations to put your height of instrument. And then when you sum your backsights and sum your foresights and calculate your adjustments, you'll come up here, and on this row, you will put the amount to be adjusted. Amount of your adjustment goes there and here and here. So you take this plus or minus that to get your adjusted elevation. Okay. Any questions? Actually, no, this doesn't go here. Just the adjustment goes there. The adjusted elevation goes there. Let me erase that. Okay. One last thing. This probably got explained to you in lecture. Make sure when you make your adjustments that you adjust them in the right direction. If you're For instance, if your unadjusted elevation after going around your loop is say 36.600, you have to make your adjustments negative because you want this number to drop to 36. So each of these adjustments would be a negative value. If your adjusted elevation is, say, 35.400, you need to add the adjustment because you want this number to go up to 36. All right. So don't go the opposite direction. If you do that, you're going to double your error instead of eliminating your error. All right. So any questions here on this extra row format? Make sure that you use this per the handout of the table shown on page 108 of your lecture textbook. Okay. Any questions here on this, on what you're doing? No, okay. All right. For those of you who have Professor Mahalati as your lecture instructor, stay on. To everybody, I will be sending you an email tomorrow or over the weekend, but plan on not having this due on Monday, okay? There's no doubt I'm going to postpone it. I just don't know how long yet. So don't worry about the due date right now. I'm not going to change the due date in the assignment on Canvas. Just know that it won't be considered late because I'm changing the due date. I'm not sure if it'd be worth it changing it in the assignment page. If I can do it, I will. But once I determine that, either way, don't expect I'm having to turn this in at your normal time, which would be next Monday at 1 o'clock. Okay. So if there's no questions, you feel free to log off. Again, if you have any questions between now and when this is due, send me an email. One other thing I wanted to say before we log off, I was getting a lot of emails, not necessarily from your lab section, but maybe a lot from the afternoon. I tend to get a lot of emails after 6 o'clock the night before the assignment is due. If you've got questions, you should be raising your questions now during lecture, okay? One student asked me if I could re-explain everything. No, I can't. That's why we have the lecture in the Zoom meeting, is to try to go over and answer any questions you have. Because with 84 students, I can't re-explain this thing 84 times to 84 different people. Not saying that everybody's going to ask me, but that's just an exaggerated example there of, you need to understand this. And if you don't wait until the night before it's due to try to get answers. Okay. So if you don't get it, contact me the night sooner than the night before. You've got to turn it in. Okay. And understand I can't re-explain everything that I just spent the last hour explaining. Okay. So please keep that in mind. Okay. All right. If there's nothing else or no other questions, all of you, Professor Scott Hallett enrollees in lecture can log off, and see you next week. For those of you enrolled with Professor Mahalati, stick around, okay? Okay, I see Ibram, how do you pronounce your first name? Ibram, okay, I see Ibram, Jennifer, Mason, Renee, and Sarah still logged on. Are all 5 of you enrolled in Professor Mahalati's lecture? Okay.
Yeah.
Okay. Did any of this make enough sense to you to be able to complete this without benefit of hearing this before an hour ago? I mean, that's hard for you to answer because you don't know what you're going to hear in class on Monday. I'm sure that it's going to be covered a lot more thoroughly than I did today, because normally all of this would have been explained to you already, and we just plug in numbers and go through the procedure of the assignment. In all of the years I've been teaching this, this is the first time, and it's because of the way the schedule worked out. And, I understand why it hasn't happened yet. So, it's nothing Professor Malati's done wrong at all. It's just the way his schedule worked out. Things just didn't work out. So, I tried to explain this as best I could as far as what a backsite and a foresight is. And I can do it again real quickly if you want, or if you want to just wait until your lecture portion covers all this. That's up to you. So um, I'll ask you this: do you want me to repeat and show any of this again right now while you're here? Okay. All right. Well, we'll just move forward then, and we'll see what happens in lecture on Monday. And I will just look for my email regarding when the assignment's going to be due. Okay.
Quick question.
Yes.
So since we all do have we have our class on Monday, and then would we see you prior to this being due, or no?
No, I will inform you when the due date when the due date has changed.
Okay.
Well before your lecture on Monday.
Okay.
That will probably be done tomorrow or Saturday. So no, and I'm telling you right now, it's not going to be 1 o'clock on Monday, and I'm not going to make it due Tuesday either. If you just get exposed to this between 4 and 6 o'clock on Monday afternoon. So I'm kind of leaning toward stretching it all the way out until Thursday. However, that means you're going to have 2 assignments due a week from Thursday. So, I'm not sure yet. I'm going to talk to Professor Scott Hallett too. She's been teaching this a while, so we'll try to figure out the best way to do it. But the good thing is next week's lab is going to be the exact same procedures as this week's lab. So I'm not going to have to re-explain any of this next week. It's the exact same stuff you're doing today, just in a different location with different numbers, but it's the same assignment pretty much. So it's not like you have to relearn anything for next week's lab. Once you learn it in lecture this week, it's going to the same thing's going to apply to lab 4. So that's the good part. So if you have 2 assignments due on the same day, you'll have 2 weeks to do it. So that's what I'm leaning for on right now. Okay. So if none of you want any further explanation, I guess you're free to go and look for my email in the next few days. But yeah, rest assured that this will not be due Monday at 11 a.m. Okay. Sure. Okay, so let me show this real quickly on the whiteboard. Okay, you've got your lab book or your lab sheet. This is not proportioned correctly here. It looks more like this. And on this side, you've got the grid. I'm not going to try to draw the whole thing, but it looks something like this. And I think there's 4 or 5 columns. Okay, and then skinnier rows that go across. And then over here, you've got this other grid that is much smaller. They're almost little squares. Okay. Actually, they're more oblong. They're taller than they are skinny. Anyway, and here's where you would say, lab, exercise, whatever, and the title, and all your data this week. Your station, your backsite, HI, foresight, so on and so forth. And over here is date, equipment, and the little sketch, the signature, the north arrow. Okay, that's what is going to be shown on figure 3.2. Okay, so you're going to get this, then you're going to get another piece of blank paper, this with the same grid on it. Actually, I'm just going to erase the blue stuff on here. I'm going to show you what the manhole and your extra okay, so you're still going to have the same sheets over here, blank sheets, except now your manhole sketch is going to go over here. With the rectangles and the circle. And here is your temporary benchmark. Except you're going to draw it with the text going this way. Just like it's shown in the lab manual. It's drawn sideways in the lab manual. Okay. Then over here will be your adjustment calcs. If you run out of room on the first page. Okay, that makes sense. 2 separate sheets of paper, but on using the same graph paper. So just print 2 sheets of the blank paper, put figure 3-2, figure 3-2 on one of them, and on the second one, do figure 3-4 and your remaining adjustment calcs. All right, is that what you're looking for? Okay. Nope, just figure 3-2. And the only thing you're going to submit where are the pages that I gave you a sample of in the files portion of Canvas. So look for exercise 2, figure 3-2, and look for exercise 3, figure 3-2, look for exercise 3, figure 3-4 with the sample in the files of Canvas, and that's what you're submitting. So 2 pieces of paper, they'll look just like I just showed you, one with your normal stuff on the right and left, and then the second sheet with the manhole cover, the manhole sketch on the left, and your remaining adjustment calcs on the right. Absolutely, you should. I don't know his schedule. I think Professor Scott Hallett is contacting him, and she's supposed to be contacting me, but because that was the way everything was arranged at the beginning of the semester, we want to make sure that you learn this in lecture before I throw it at you in lab. Okay, and that's exactly what didn't happen today. So we'll wait. If he doesn't cover this on Monday, then we'll have to go to plan B, and I don't know what that will be yet. We'll wait till after Monday to figure that out. But this will not be due until this is covered in lecture. Just be sure of that, okay? Okay. Anybody else that's still logged in? Any last questions? Okay, if not, look for my email here in the next few days, and we'll talk to you next Thursday.